that brings us to the next topic, the digital twin. And for the definition of the digital twin, let's first discuss what a digital twin is. In our institute, we had a while ago the joke that even a drawing is a digital twin. So actually, there's nowadays very good definition of different levels done by Kritzing et al. From 2018. And that states that if you just have a digital model, whether it's a drawing, a computer simulation, finite element, CFD, and there's no effect of the physical object, so in our case, the ship, then it's just a digital model. So that means if you build a finite element model of your ship, it's not a digital twin, it's just a digital model. Then the second category is a digital shadow. So in a digital shadow, there's a one-way data flow. So that means a change in the state of the physical model is reflected in its digital copy. So for instance, if you have certain elements that are maybe deflected or bent over time, and you are updating that in your model, then it's a digital shadow because it adapts to the actual physical ship or the physical structure, but there is no feedback in the other direction. So it is still not a digital twin. And you can probably guess what a digital twin is. So the definition of a digital twin is that there's a two-way data flow. So that means you have an exchange of data between the digital model and the real model. And the digital copy receives the physical object states, processes it, and returns the newly generated data. And on this basis, you usually are able then to make a decision or draw a conclusion. And in order to show you a couple of charts for digital twins, both that you see here, they are built for different purposes, and that also is causative for some of the small differences between them, but overall they are rather similar. On the left-hand side, there is a digital twin for the ship life cycle, and on the right-hand side, there's a digital twin for a machinery unit from the electric motor to the propeller, including the shafts and the ice loads. And if we start, so we have in both cases the physical twin, which is the ship instrumented with some sensors. And these sensors, that actually is also our connection to the hull monitoring, they are then receiving data, they are the measurements, and they are then communicating with the virtual entity. So in this case, we have the virtual entity on top on the right-hand side, and here we have it here at the bottom. So in the digital twin that we have here on the right-hand side, we also used those data in order to trigger simulations, and those data were fed back in the database. And in both cases, in the end, this data or the gained knowledge is then providing a decision support. The decision support can either be reduce the speed because the load on the structure is too high, or you still have, for instance, when we talk about the machinery, still sufficient capacity. You can increase the RPMs because the supports and the gears are still running well. Something like that. And the only differences between these two is that on the right-hand side, we still have everything fed into a database because measurement and simulation results were also aligned with each other. And on the left-hand side, we have the operator that is then making a decision, for instance, the captain, which is then fed back into the physical entity, in our case, the ship. So this is for naval architects and maybe in general, the classic setup of a digital twin. And if you look at the digital twin and the exchange, the digital twin that can of course be a finite element model or a CFD model, or maybe both. But if you now look at it from your own experience, the digital twin, or if you would have to let the digital twin interact with the physical ship, and if it was a finite element model, you will not be able to have a proper real-time exchange of information if you always have to solve a finite element model. And this is actually where some of the more recent technologies come in, so that we can use cloud computing, Internet of Things, artificial intelligence, machine learning, and big data in order to enhance digital twins, to connect also our digital models with the sensors that we have on board. And especially artificial intelligence, or I rather prefer the term machine learning, might play a significant role here, because with machine learning, you might be able to pre-compile certain things, different states, different interaction scenarios, and use these pre-compiled information then with your machine learning model in order to process the information that are coming from the physical ship. So there's a lot of, I would say, potential that has not been fully used, or that is in the process of being used. Yeah.